Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Well, the sound of that music means it's time once again for JS Party, where I think it's safe to say that we are throwing a party every week with JavaScript. My name is Jerod Santo, and I'll be acting as your interim head coach this week, your part-time party planner, kind of like that dependency which just injects itself all up in your functions. I'm here to have a party, and I'm very excited to introduce 3 new panelists. If you didn't listen last week, then you do not know that we've expanded our list of panelists, and we have a bunch of awesome people whose voices you'll hear on the show from week to week. And this week we have 3 brand new people, and I'll introduce them now. So the first is Suz Hinton. Suz, thanks so much for joining the party.
Thanks for having me. I'm very excited to be here.
And we have Kevin Ball. Kevin, what's up, man?
Hey, K-Ball here. Excited to be here.
And last but not least is Feross Aboukhadijeh, if I said that right. Feross, how you doing?
That was perfect. I'm doing well. I'm hyped to be here.
Very cool. So I've practiced your name enough times because we've had you on the changelog, and I've had the chance to read it and say it, and it's actually kind of fun to say once you learn it sounds like booking a DJ.
Yep.
So last week we were talking about JavaScript, kind of its relation to us and to the different panelists, things that we like about it, what its draw is. And one of the themes of that show, at least for me, was this idea of ubiquity and really kind of the way that it has permeated different spaces. And I think the real thing about JavaScript language, especially once Node came around and enabled that, is it's so versatile. And so this week we really want to highlight just how versatile JavaScript is, and do that by having a discussion all about kind of the fringe, edge, weird, zany, awesome, different things that people do around the world with JavaScript. And I think y'all make a great panel to talk about this because each and every one of you are doing something different and interesting than myself with JavaScript. So where should we start? Let's talk about just the craziest stuff. What are people doing with JavaScript that maybe you wouldn't have believed was possible 5-10 years ago?
I want to hear about the IoT stuff. Look like both Suz and Feross have been playing with that, and I haven't had a chance yet. So what are you guys doing with that?
I wouldn't describe what I've been doing with it as playing with it too much. I want to hear what Suz has to say, because I just got one of those free web lights at a Chrome Dev Summit, and it's like a hello world for WebUSB. You plug it in, and then the browser recognizes it, and it lets you change the light on the little device. So it's like proof that WebUSB works. But other than that, I haven't played with it.
Yeah, it's really cool. I actually have a couple of those too for us, and I picked them up at the Chrome Developer Summit as well. And I've been handing them out to everybody because I ended up with a bunch of them, just to show people how magical it is, and for them to get their head around the fact that JavaScript and hardware, now that it's a little bit more natively accessible in the browser rather than having to do all of these kind of ridiculous hacks to get it to work, now people are kind of understanding where the benefits are with that. So I've definitely been throwing myself deep into WebUSB and trying to create my own devices that will redirect you to websites, and you can start playing with it. So that's been really, really awesome.
WebUSB, can you describe that and what it allows?
Yeah, that's a really good question. So WebUSB is a new spec that is going to be hopefully a new API in the browser. So you can access it in a very similar way that you access things like local storage or the web audio API or even just the fetch API. So it's supposed to be natively available in the same sense, and it's permission based. So it's kind of like when you want to do something with WebRTC or video, or you want to record somebody's audio on a mic, you have to ask for the user's permission to get buy-in for that. So WebUSB is a very similar exchange in that way, where if somebody plugs in a USB device and it's WebUSB enabled, then they can actually give permission and start interacting with it directly from a web page, which is sort of what that web light actually does, which is really cool.
It seems like the kind of stuff you could do with USB is infinite. Like the types of calls that you can make into a USB based device could be so varied. Is there like a minimal API into the devices, or is it just like a socket connection? What's that look like?
Yeah, it's very similar to the regular libUSB API. So if you've worked with the low-level USB API on just operating systems such as libUSB, for example, it's very similar to that. So at the bare minimum, you're able to connect with the device. You're able to set certain configurations on it. And then you can claim certain interfaces on that USB device, such as I want to claim the endpoint where I can write data to the device to communicate with it. And I also want to claim the interface that allows me to read responses from the device itself. So it's actually pretty minimal and it's very low level. So you have a lot of freedom to build things such as JavaScript drivers for hardware directly on top of those devices. And so what I'm hoping to do and what I'm hoping to see the community do is that people are going to be writing these drivers so that people have a little bit more high level access to these WebUSB devices.
Does it handle USB hubs?
No, I don't think so, unless it was a super smart USB hub. But the USB device has to have the right descriptors and things like that, just in order to be able to advertise that it has interfaces. So it still has to follow that USB spec. And so there are USB devices such as hubs that aren't necessarily what I would call like smart devices, where they're not really trying to have a conversation with the computer other than just being a proxy, for example. So I'm not sure you could do much with that, given that it sort of just registers a whole bunch of different devices. But I would say that you could talk to the devices that are actually plugged into the USB hub.
That's probably what you want anyway, right? You don't really want to control the hub. You just want the devices plugged into the hub to work.
Yeah, if the hub is transparent, that's phenomenal, right? You could imagine, setting up an entire, show. Just plug in your lights, plug in your sound, and go to this website, and we're going to have a party for you.
Exactly.
That sounds almost like a JavaScript party.
I'm trying to do some pretty intense stuff with it right now. So what I'm trying to do is build a proof of concept that allows you to write, let's say, Arduino code in the browser, and then instead of having to have a companion Chrome app or something that uses Serial, you can actually flash microchips by writing C++ in like a code mirror, instance or something like that, and it can compile it and then upload it to the device. And so instead of having Electron apps and things like that and WebSockets, which we've had to do in the past, you can actually do all that native in your browser, which means that people don't have to have these super complicated tool chains installed on their machine. They can just get going with hardware immediately.
That's so awesome, man. That's amazing. Being able to just plug in a device and have it not have to install anything and just have everything be through the browser. That's like so easy to help people get started. Because normally you spend so much time just in the installation phase and in the getting it set up phase, and you get a new smartwatch or something, and then it wants you to install its a native app that's poorly coded, probably insecure on your computer, and then maybe in the future that could just be a web page, and then we get the browser sandbox to keep us safe.
That's exactly what I want. So I really want to see the unification of those interfaces where there are all these weird bespoke artisanal little C++ apps that you install on your computer and you never really open them again. And being able to just go to a web page, configure your device, and then exit out again is just it's almost like the NPX of configuring devices, I guess. It would be really cool.
Well, and firmware updates suddenly become seamless. Just you don't have to download it and figure out how to get it on the device. Just plug the device in and go to the website.
Exactly. I'm so excited.
That
so
is
yeah,
awesome.
I feel like you're all getting it.
You guys are getting this so much better than me. I'm sitting over here thinking, what would that be good for? And then you're just naming off thing after thing. I'm kind of amazed. Isn't there? I mean, you mentioned it was permission based. One of the things about the web is like everything lives in the sandbox and in the browser, and it's almost like a separate little operating system that they can't poke through. And we're basically like poking a big hole right through our browser, into hardware. Does that concern anybody, or is it? Do you think the Chrome and the browser teams can just handle that? No problemo.
There's definitely concerns that can be raised. And if you, so the WebUSB spec is available online right now. The last update was actually last week, and there's a whole section on security, and that's definitely something that's top of mind for them. Part of the reason why we've never really had native serial, which is kind of a little bit different from like libUSB support in the browser, is because of security concerns. The WebUSB spec, which I wasn't expecting because it is such a low-level, complicated, not super high-level spec, but they do have some really great human readable sections in it, and one of them is actually security. So I definitely recommend you read up on that, but it is something that they're thinking about.
Suz, could you explain the part where you plug in the device and then it can advertise that it has a website that goes along with the device, so that you don't have to remember the URL to go to in your browser? So you just plug in the device and then it pops open a page in Chrome or whatever browser right away? Like, how does that part work?
Yeah, that's actually really exciting. And I'm sure that was the magical part for you for us when you plugged in the WebLite, right? Because the WebLite does that really well. Yeah, so the spec is, and I might be actually explaining this slightly wrong, but the high level idea is that the WebUSB spec introduces a concept known as a certain custom descriptor that you can set on your actual device. And so when you plug the device in, Chrome is going to look for that descriptor. And if it finds it, it's going to say, this is a WebUSB device. And the descriptor is really just a URL string. So if you have a recommended website that someone goes to that that you've set up to work well with that device, you can actually have that device tell Chrome, this is where this person probably should be going. And it pops up as a little notification, very similar to, it's just really a native browser notification that pops up, and it asks you if you'd like to go to that website. So again, there's a very deliberate thing where the user has to make that decision. And it's not just like the good old days of, even like Feross's most annoying website where it just kind of pops it up for you. You can actually make that choice to go there. And then as Feross said, you never have to memorize where to go to get your hardware driver or anything like that. You don't have to look at the manual. It's just there for you as soon as you plug it in, which is awesome.
What's this most annoying website you mentioned?
Oh, yeah, that's the thing I gave a talk about at .js last December, and it's basically a collection of all of the worst web APIs that I could find, and not worst. I shouldn't say that. A lot of them are useful and powerful. Some of the APIs I found are really old. They're from the Netscape days, and they're like it's pretty surprising that they still work today. But my goal was to basically collect all the different web APIs that I could find and put them into a single site that would try to be as annoying and obnoxious as possible. So if you can imagine like getting prompted for your webcam and your microphone and, storage on your computer and having like pop-ups come up every time you interact in any way, any key press or mouse down or anything like that, you just get pop-ups that fly around your screen, and you apparently can move windows around the screen. There's APIs for this. Window.move by and
if you open
to.
it. Yep.
Nice.
Yeah, so beware if you go to it. It's quite aggressive. It like logs you out of all your logged in websites. It does lots of things that you wouldn't expect a page to be able to do.
It's really funny. And I guess what I was trying to say was that WebUSB tries not to do that. And it's just a little notification that suggests you go somewhere instead. It doesn't just like throw you into something that's going to destroy all of your USB ports.
Kind of reminds me of the QR code movement. Like people slap a QR code like on a lamppost or around the world, expecting us to just point our phones at it, and like you have no idea what that's going to do. So why would you that? Just seems dumb. So similarly, pop this USB device into your computer, and now it's going to take you to a website of which you don't know what it is.
Exactly. It's a little bit magical.
Do y'all remember how Windows had auto run for a while. Like you'd pop in a DVD or CD and it would just start running the program on the CD.
Yeah, it was so scary. Wasn't there a key you could hold down? Like you hold down the control key or something and it won't, and then you can just go and not have that thing take over your computer.
Yeah, we used to, like when I was in, I think, middle school, like when you first start learning a little, tips and tricks that other people don't know, and you have like lab computers at school. And I think it was, autoexec.bat on Windows back in the day. Like you could just, it's a batch file that will just auto execute when the machine boots. And that's pretty much how we caused a ruckus in the computer labs in school, as such things like, let's just auto run this thing without any sort of reason not to,
Oh my gosh, I have a story about that I have to share. So you know the startup folder there's a folder called startup under programs on Windows, and you could put like shortcuts to applications in there, and they would start up automatically when the computer started up. And I made a script, like a bat script, a batch file that just ran the shutdown command and put it in the startup folder. So as soon as you turn on your computer, it would turn it off immediately.
Feross, your pranks date back a really long time. I'm impressed with this. Your commitment to continually screwing around with people is impressive.
Yeah, it's just the way my brain works. Anytime I see some system described, I just immediately see how it could be used incorrectly. I don't know why my brain just I have a problem, I guess.
There are certain people who are better at like breaking things than others. Like they have a knack for knowing the exact wrong input in order to break a thing, and these become penetration testers and whatnot. So it sounds like you definitely have that knack.
Incredible QA team.
Yeah.
I just never have the cool ideas like, let's just make this thing reboot itself. But I was always the guy who once Feross, figured it out onto a computer, I would be like, okay, let's run this on all 500 of these at a time. So I was always like the catalyst to do more or worse.
Suz, I had one more question about WebUSB. Like I was actually thinking, so if a vendor or, if someone who made a device was doing this WebUSB thing, so they're advertising with the descriptor that this is a WebUSB device, is it possible for any web page to get access to that device? So like, in other words, say I didn't like the interface that the device vendor created, could I make my own and like sort of reverse engineer their protocol and then just have my web page talk to the device? Or can they like somehow DRM it and like make it so that I can't do that?
Feross, I'm so glad that you asked. Technically, yes, you can basically go and create your own thing if you really wanted to. That being said, there's if they are able to obfuscate, like let's say their JavaScript, and there's some kind of sneaky exchange that happens, and they've got the device lockdown, then you'd have to reverse engineer that. But if you're able to do that, there's nothing stopping you from talking to a device, even if it's not the device that you've made yourself. So it's pretty cool. You can totally create alternative interfaces, which I think is probably the most attractive part of this, is that, when I've seen this in the web community, when the web community is not happy with something, they'll just create something completely new to make a point and to improve on things. So I think that that's something that we're going to start seeing.
That's awesome.
That is really cool.
Last question I have on WebUSB is, sounds like the kind of thing that won't be a reality anytime soon. What's the status of the spec? And I know we have it in Chrome to a certain degree, but what's the likelihood of, the IoT manufacturers, the people making these devices, actually, using this in the next couple of years? Is there a chance?
Yeah, that's a really good question. So right now it's available to approximately 56% of people globally. And what that actually means is who is using certain versions of like the latest Chrome and who is using Chrome on an Android device too. Because right now you can plug the web light into an Android device if you just have like the mini USB kind of converter plug, and it works really well, which is really, really cool. And so that is a substantial amount of users, but it's not everybody, right? So, and the spec, if you look, it's still in draft status. The arguments that they make at the beginning of the spec are super compelling about hardware manufacturers and how this is a cross-platform, I guess, strategy to not have to create these programs that run correctly on everybody's computer, right? The browser is smoothing that over for you to a certain extent. So I'm hoping that advantages like that will attract manufacturers to offer that. As far as whether we'll see that happening, I'm not sure. And I will admit that I've been guilty of sneaking WebLite devices into the offices of Edge developers at Microsoft. So no promises, but I've been trying some gentle persuasion. So it's really up to people to advocate and to make things with this technology and make awesome things to show the potential of it. Because what people need, as usual, it's the same with CSS Grid. You know, we need people to go out and do something with it and actually show that it's a very compelling thing to have in every single browser.
This episode is brought to you by the O'Reilly Fluent Conference. Make your plans now to attend Fluent in San Jose, California, June 11th through June 14th to learn the latest JavaScript tools and methods. Be part of what past attendees call, quote, a great center for modern web development and disruption, and, quote, the best place to see the current state of the web. Use the discount code JSParty to save 20% on most passes. Learn how to build a better web with better user experiences at O'Reilly Fluent Conference. Head to fluentconf.com to learn more and register.
All right, let's turn our attention towards a completely different use of JavaScript, which is torrents and peer-to-peer networking in the browser. Feross, you've done a lot of work in this space. Why don't you share with us what's up with WebTorrent and some of the work you've been doing with WebRTC?
The goal of WebTorrent was to build a torrent app that runs in the browser. So with the goal being to eventually be able to build something like a peer-to-peer YouTube or something along those lines. So you can imagine, going to a website and then it wants to fetch a video and it can do that from other people who have that video. Those people could be people who are on the same web page as you, watching the same video as you, potentially, or it could even be from someone running a native app on their computer, hosting that video because they want to make it available to the peer-to-peer world. And so in order to do that, in order to have, different people's browsers talking to each other, or even, your browser talking to a native app, we need a protocol to do that. And so the browser gives us WebRTC for that. WebRTC was originally created to be able to do video and voice calling in the browser. So you can think of something like Google Hangouts or Skype in the browser. But there's also one component of it that is called the data channel. And the data channel is, it's basically like, you can think of it like a WebSocket. So it allows you to get basically just a simple connection between you and another peer. And so this is the first time this has been possible. So with a WebSocket, you're connecting a client to a server, so a browser to a server, right? But with WebRTC, you can connect a client to a client, or in other words, you can now connect the browser directly to another browser without going through a server. And so that's the sort of the new capability that we got with WebRTC. And the interesting thing to me is like WebRTC actually was mainly about giving this ability to capture the webcam and to capture the microphone, and then to send that to another peer, and then doing quite a bit of complicated video and voice magic. So the quality can adjust dynamically depending on how much of your CPU is being used for encoding and for how much bandwidth you have available, and there's all these options and configurations and things that like all video and voice apps need. And so that's what like the focus of WebRTC was. But as part of that, they introduced this peer-to-peer capability, because being able to connect directly to somebody is actually really good for latency. And you want low latency when you're doing a video or a voice call, because it makes the experience much better. You don't want to have to send all the video and voice to some data center way across the world, and then back to someone who you're just talking to, who's in the same city as you, as an example. So being able to just connect directly to them improves the call quality quite a bit. And so in that way, we were able to get peer-to-peer on the web, sort of via this back channel. That's how I think of it. Yeah. And anyway, the data channel is really cool because you get this very simple WebSocket-like API that lets you build lots of different protocols on top of it. So you can really build anything that you want to build. That your imagination is the limit in terms of what types of applications we can build on top of WebRTC. And so WebTorrent is just one of those uses. We basically put the torrent protocol on top of WebRTC instead of what it's usually used on top of, which is TCP and UDP.
That's pretty interesting. So you can basically auto scale your ability to serve content or whatever it is based on how many people are interested, because everybody who starts using it and they just need a browser to use it, suddenly they become somebody capable of forwarding that.
Yes. And the other thing that's interesting is there's no permission prompt for this. So it's not something that is considered worthy of a permission prompt, because you're not accessing the user's webcam or their microphone. And the only thing you're really using is their bandwidth for this. But you can already, create data in the browser with JavaScript and then send it up to a server via an XHR request or a fetch request and use up all their bandwidth if you want to. So in terms of like new capabilities that the I know it's a funny way of thinking about it. I heard someone laugh. Yeah, it's the point is that like the thinking here is that this doesn't really enable a site to do anything it couldn't already do if it wanted to. So there's no permission prompt on there. And so that's pretty cool. It means that the experience of using a site that's serving data this way is just as seamless as using a site that's completely centralized.
Yeah, for us, I don't know if you've been following some of the stuff that Surma from the Chrome advocacy team has been doing, but he was trying to use the data channel for similar things where he was controlling like CSS and the background style and stuff like that, I think, of like someone of the other peers like web page, which is so cool. I'm really excited about this idea of using the data channel for actual communication and setting up like your own protocols in order to have almost like this sneaky way of communicating without having like, well, I mean, you could still have eavesdroppers, but I just think it's a really interesting concept.
So I think I saw this. It was called Comlink. It's a sort of like an RPC mechanism. So one browser has a bunch of functions in it, and then those get exposed to the other remote browser as local functions that it can call that return promises, because it's obviously asynchronous. So in one browser you call these functions and they actually execute on the other browser, and then you get the return value from those functions, as a promise that resolves to that return value. So that's pretty cool. But I mean, you don't necessarily need his Comlink library to do the same thing. You could make your own protocol that just, when you get a message event, you just eval. You could just eval the text that you're given, and that's I think that's basically what it's doing.
What could go wrong?
Yeah, exactly. This is not legal advice to eval text as it comes in.
But kind of related to Feross's point, you could implement all this routing through a server too, right? Like there's nothing theoretically new in functionality there, because you could just use a server to pipe things through. What's really interesting is kind of the point about cutting out the middleman, cutting out the tracking and things like that.
Yeah. So it's worth pointing out though that to actually do a peer-to-peer connection with WebRTC, you can't just know someone's IP address and connect to them, which is basically what you can do with TCP and UDP. If I know someone's IP address and the port that they're listening on, then I can just connect to them by opening a socket, and then now I can just send them data and they can send me data. With WebRTC, the process is a little bit more involved. So you have to get introduced to the peer. And this is because most of the time we're behind NATs, which are that stands for network address traversal, I think. So it's basically like a Wi-Fi router. If you're behind a Wi-Fi router, you don't actually have a publicly addressable IP that someone can connect to. You have a fake local IP that's given to you by the router, and the router itself has one IP that sort of everyone is sharing, if that makes sense.
Right.
Yeah. And so basically you don't have a way to tell an IP address to the world that people can connect to. And so there's this sort of mumbo jumbo process that you have to go about to actually poke a hole into the NAT and have people connect to you. And so for that reason, among other reasons, the process is basically, I want to connect to somebody, so I generate a blob of text and then somehow get that blob of text to the peer I want to talk to, which is kind of a weird catch-22 because I want to talk to the peer and I haven't connected yet, but now I have to get this blob of text to the peer that I'm trying to talk to. And so this is where you need to be sort of introduced to the peer. So someone who has the ability to get the text to that peer does that for you. So that's typically just a server that's the website that you're both using, which will have a WebSocket, and then you just use the WebSocket to get the text over to them. And then they do the same thing in reverse. They generate some text and send it back to you, and that text contains all the information needed to connect. So now you've each given each other this blob of text, and then now you can directly connect your browsers together, and you can get rid of the WebSocket, and you don't need the server anymore. Now you're directly connected.
And for us, is that like the stun and the turn servers, right? The stun is like what does the IP stuff, and the turn is what kind of like negotiates the two peers that want to connect?
Sort of, yeah. So stun helps you discover your own IP address, which you don't know normally because you're given the fake local IP from the router. And so stun is just a way to figure that out. And then the second part is called signaling. So signaling is just sort of how you decide to help peers get connected to each other. And then turn is actually something different. So turn, there's all these acronyms with WebRTC. That's one of the problems with it. It's really confusing. So turn is actually what you use if you can't connect, which happens in some situations. If you're behind an extremely restrictive firewall, which is sometimes the case in enterprises, then the peers can't actually connect. And so when that happens, you can fall back to your own centralized communication approach, maybe using a WebSocket or something, or if you want WebRTC to just handle that for you, you can specify a turn server, which the easy way to remember is turn has the letter R in it, which stands for relay. So this is basically a server which will just shuttle the traffic between you and the peer in a centralized way, but in a way that it can't see what's going on. So it's encrypted through the turn server. So the turn server is just kind of an oblivious, tunneler. And so that basically the way it works is each peer can connect to the turn server, but they can't connect to each other. That's because the turn server has an IP address that's just public and easy to connect to. And so you both connect to the turn server, and then it shuttles your traffic to each other. And that's a last resort because that sort of defeats the whole point of peer-to-peer. But it's useful for building a reliable service that will always work.
For that setup process, do you need a two-way exchange of information, or can I take that blob of text like it's an address and throw it up on Twitter and suddenly people can connect to me?
Yeah, so unfortunately it's two-way. I really, really wish it was one way. So yeah, if I want to connect, if I want to let anyone connect to me, there's no way for me to generate a blob of text and just post it online, and then anyone could use that to connect to me. That would be so nice, because then we could build really nice topologies, peer-to-peer topologies, using really cool data structures. Like, for example, there's this thing called the DHT, which I don't have time to explain, but the gist is it's sort of a way to sort of find anyone you want to talk to. And you can have peers, millions and millions of peers, but yet you can sort of just given a name, kind of find anybody and then connect to them if they want to connect to you. And there's no centralized routing involved. So it's just really scalable way to have a giant network of people. But the way that works normally is that you just sort of have an IP address and a port that you're listening on that you can just post sort of to the message board. You just post it and say, anyone who wants to find me, here's where I'm at. You can't do that with WebRTC. So it makes it really hard to build up those kinds of topologies. You need to have a two-way exchange, sadly.
Interesting. I wonder if you could use something like the turn server approach, where you have a server that'll essentially is in a known place, and then you can sort of broadcast that and use that to set up your, I don't know, then you've got a centralized body again. But
yeah, one thing that you might be able to do is have trustless servers, so that you don't trust them, but there's maybe 20 of them. So they're just sort of serving a role of helping you out, but any of them could go away. None of them is essential to the system.
That sounds like a blockchain ledger.
Yeah, but don't you need a directory then? And so now you have a centralized index of trusted nodes. And so who controls the directory type of a thing? It seems like a centralizing force.
Yeah, I mean, and the big elephant in the room here is that we're accessing all this through a website. So there's a domain and there's someone who's controlling the website.
Right. Yeah.
Yep.
It's peer-to-peer, but there's still there's still the sort of centralization that the browser and that the web kind of enforce on us.
So Suz mentioned the blockchains, and I can't help but think about that. I heard a comment. A lot of these teams are trying to rebuild decentralized social networks, file sharing things. Like DTube is like, YouTube is censoring things. Let's have an uncensorable, YouTube, and then on a blockchain. And then there's another one I think called Steemit, which is like decentralized writing with payment channels and all this kind of stuff. And I heard a comment that, there already is a very popular decentralized social network for sharing files, and it's called BitTorrent. And it's been very active and very successful for years. And I thought that was a good point. I can't help but think in the case of WebTorrent, you're then introducing, I know there's what's the term in BitTorrent? Not the seeders, but there's like kind of like the turn servers, or there's like a relay, or there's a broadcaster of some kind. Yeah, trackers. With WebTorrent, you're required then, because you're using WebRTC, to have a little bit more, centralization. Like you said, there has to be a website involved. And is that not necessary in BitTorrent, but it is with a WebTorrent implementation?
Yeah. So when BitTorrent was first created, they had these things called trackers, and they were basically a place where you'd go and announce that you're interested in a particular torrent, and you would post your IP address and your port, so that anyone who also is interested could go there and find it. And so it was basically a key value lookup, where the key is the torrent's identifier, and then the values are just like an array of all the different IPs of people who are interested. And then they found a way to get rid of that using the DHT data structure I mentioned earlier.
Okay.
And so with that, you don't even need trackers. You can just sort of you can just find each other. And there's no server involved. You just sort of ask peers that you're already connected to help you find the person you're looking for. And you just sort of get closer and closer, and you just keep asking different people until eventually you find the right one. And you can do that sort of provably quick. So it's not just like a hopeless cause that's going to go on forever, where you just keep asking random people. It's actually guaranteed to sort of terminate after a pretty short number of hops. So yeah, I mean, that is one downside of WebTorrent, and that we kind of reintroduced that centralized sort of introduction point between the peers. Yeah. But I mean, on the other hand, it's a lot more accessible because it's in the browser. For sure. So it's like a trade-off, right? Like, you want to make things easy for people to use, then you want to put it in the browser, so you don't need them to install things in their computer. So that's along the lines of the WebUSB stuff. I think it's similarly powerful in that way.
And I think I read recently, correct me if I'm wrong, that some WebTorrent stuff made it into Brave. Do you have an announcement around that, or am I misremembering? There's like native support inside of Brave or something like this? Yeah.
So you know how like browsers can usually show you PDF files? There's a PDF viewer built into the browser.
Yeah.
That's so that you don't have to open up an external program to view a PDF. Well, Brave decided they wanted to do that for torrents. So when you visit a torrent file, instead of needing to open an external program, it'll just open up directly in the browser. And so that's powered by the WebTorrent implementation.
Totally random, blowing things out. I'm wondering if you could combine WebTorrents with the WebUSB stuff we're talking about, and just essentially ship a little USB device that knows how to connect via cell networks or something like that, and could be used to sort of do that setup process for you. I'm wondering, so that you basically, so I don't know enough about this space, but I'm wondering if there's a way you can hop around that need for centralization by having a device.
Oh, that's really interesting. Maybe you could do it with Bluetooth, Bluetooth Low Energy, because can't you send data over that by broadcasting stuff?
Yeah, you can set up meshes and stuff like that, which would be awesome.
Which opens up a whole new ball of wax around the scuttlebutt stuff and a lot of the decentralized stuff going there. I think we should do a show, not this show, but a show about those kind of things, because it's fascinating to me.
Hey everyone, I'm Tim Smith, senior producer here at Changelog. You know how important it is to stay in the know, and our weekly newsletter helps you and thousands of other developers do exactly that. It's the developer news that matters, nothing more and nothing less. Visit changelog.com and subscribe today.
So there are so many topics to talk about. We don't have time to cover. Of course, there's tons of generative art going on. Gaming, there's multiple projects for doing 2D and 3D games. Even people doing stuff with React and Vue and SVG, right? Like people are making SVG do crazy things. We have people doing AR, VR, JavaScript. The TensorFlow team now has TensorFlow.js. So in case you were sick of training your machine learning models, I guess, on your server farm, you can use people's browsers. I'm sure there's good uses for it. I just can't think of why you'd want to do that. But we have other things to talk about.
The things.
Yeah, exactly. What is that? Atwood's law,
Yeah,
I think.
that's the reason.
Yeah, if it can be written in JavaScript, it will be, or something like that. Butchering it, but along those lines, here it is, TensorFlow.js. But Kevin, you wanted to talk about DSLs, which is not a topic I would have thought of with JavaScript. I definitely have used them lovingly and even tried to craft a few in Ruby, which lends itself very well to writing domain-specific languages. But this is a topic you're interested in. Why don't you kick us off and tell us what you're talking about here?
Yeah, for sure. So really this comes from Babel. Like Babel is this incredibly powerful tool, and we've kind of just put it in our build chain and think, oh, that's for building, future JavaScript. That lets us get to new versions of JavaScript. But really, it's a compiler where you can create new features of the language regardless of what they are. So we saw this a little bit with the the React team building JSX, and they did it as a Babel extension. So now you suddenly have an extension to this language that just works with JavaScript. We could take that a lot farther. You could build out incredibly powerful domain-specific languages just as Babel plugins that are going to compile down to JavaScript. And as we've been talking about, JavaScript can go everywhere. Imagine having a USB-focused DSL. Imagine having a torrent-focused JSL. All sorts of possibilities. I'm
now just thinking about a USB-focused DSL, and I'm getting excited. Suz, is that something that you would be interested in, especially with how much kind of not research, but educational work you do with your live streams and kind of like bringing people to these technologies? It seems like a DSL for specific use like that could be very powerful in your hands.
Yeah, I definitely agree. I think that I sort of touched on this earlier, but I just think that this stuff is still so low level that that's what is intimidating people from getting started. And, people tend to come into programming quite commonly by learning JavaScript, and then they feel like jumping to WebUSB might just be too big of a gap to kind of jump at first. So I actually really do like that idea of having a DSL for WebUSB.
Potential open source project for somebody out there. Just throwing ideas out. Go ahead, Kevin.
Well, in the break, y'all were talking about a really fun application, Parcel Tongue. Do you want to go more into that?
Yeah, so there was a talk that was at JSConf AU just very recently, and it was about ASTs. So Craig Spence gave a talk called Fantastic ASTs and Where to Find Them. So if you're a Harry Potter fan, you'll know that that's a riff on Fantastic Beasts and Where to Find Them. And he ended up inventing a new DSL or a new programming language called Parcel Tongue. And it was just like this delightful Harry Potter themed journey through, well, we don't just have to have JavaScript, transpiling down to JavaScript, but we can make up our own programming languages and just insist on writing all of our web, language or web functionality with a completely different language and never really have to think about the JavaScript side of it. So I thought that was really, really funny.
For those of us who aren't super into Harry Potter, Parcel Tongue, I assume, is like a language that they use.
Yeah, it's quite funny because Python is like our snake-themed programming language, I guess, in name. But
right.
This had things like s means one thing and then s means another thing.
Oh, just the length of your S's just change it, right?
It's just so funny. And every single kind of feature of the language generally started with some S's. So, you had to sound like a snake while you were actually, talking about the main keywords of the language, which was hilariously funny. So
Code
if you've seen a
reviews would be
for
so
loop
much
in
fun.
Parcel Tongue. Yeah, it was just really, really fun.
I would have
And
used
think
5 S's instead of 6 S's. Those are the kind of code review comments you get. How many S's are there?
Yeah, imagine building a linter for that, which I guess is what you would use an AST for, right? But I just thought it was cool. So I want to know Kayvol's thoughts on that specifically.
What's really fun about programming, and what always drew me to Ruby in particular, is the ability to kind of take your mental model and translate it into something that's actually going to do something. And I did Ruby before I did JavaScript, and I loved in there that I could really shape the language to match the mental model. And now with Babel, we actually have that capability, right? We can really extend this language, which, JavaScript now is pretty damn awesome anyway. But we can take it and really conform it to match the models that we're working in. And, as the language is right now, it's pretty, a lot of the features there are based on the primary use cases, right? This language developed over the course of years and years and years, using it primarily on the web. But as we're opening it up to all these other possibilities, right? Like that way of thinking about things may not actually be the easiest way to think about things. And so if we extend our view of our application to not just be, here's our application and then our build chain is Babel and Webpack or whatever it happens to be. I actually don't know if you need to use different build chains when you're down in some of these, if you're using TensorFlow.js, do you actually have to plug it into something else? But and think about that build chain as part of the application, right? It's not just configuring a set of pre-existing loaders, but saying let's define our application language, and it could be mostly vanilla JavaScript, but maybe we want to extend a few things because it's going to make it more natural for us, or maybe we want to create a language for our domain experts to program in that's just going to compile down to JavaScript so we can run it with the same stack.
So, K-Ball, could you give a couple of examples of that? Like, I'm thinking of JSX, and that makes so much sense. Putting HTML into JavaScript makes it so that you don't have to transform it into some weird set of function calls to make that work. It just you just see the HTML there. But what's some more examples of that for other domains?
Well, let's explore one maybe. So what are the key primitives in, for example, WebUSB? We were talking about doing that as a potential for a DSL. What are the primitives that actually maybe not even primitives? What are the sort of higher level functionality that you might want to expose there that right now you'd have to sort of dive down into the guts to do?
I think it would be things like even just representing specific byte sequences that mean something, right? You have these really, I guess, these really kind of obscure things that you need to do, and even just the methods that you're calling, such as transfer in and transfer out and things like that. And I'm imagining that there's probably a more ergonomic way to be able to kind of express those behaviors.
Yeah, so right now, to think about this in a DSL way, so to deal with a set of byte sequences in vanilla JavaScript, you'd basically define those as const somewhere, and then you'd set up a bunch of methods for transferring in and out of those, and you'd probably be passing those consts around and things like that. But if those actually represent functionality, if you could potentially essentially wrap those up as primitives in your language, right, and just say this is something that's always there. We don't have to import the consts and have a central file or whatever. This is just, it's part of the language.
That would be so good, because I have to write a lot of helper functions when it comes to this stuff, because some protocols expect you to frame every single package that you're sending with things like checksums on the end and stuff like that. And so you're basically writing a bunch of helper functions that doesn't really encapsulate exactly what you want to do, or you use inheritance or something like that. And I think a DSL would probably make more sense, but I'm still trying to wrap my head around the potentials of this. I think that this is a really good point that you're making.
If we think about it, right, it's all code at the end of it, right? It's not enabling you to do something that you couldn't do otherwise. It's about ergonomics. It's about, sort of matching the code that you write to the mental model that you want to have and that you want to think about it. But that then enables you to be thinking about this stuff at a higher level.
How would you do this with torrents? I'm now wanting to go over to Feross's side of things.
I mean, so part of the torrent protocol is, the torrent protocol itself is pretty low level and has the same types of magic byte sequences that WebUSB has. So I could imagine that just being kind of part of it, part of the DSL. I'm wondering though, how easy it is to actually change these DSLs, because I can jump into the code for sending stuff to peers, and look at the protocol and sort of change the constants and stuff because it's just JavaScript. But if this was part of the DSL and I wanted to change sort of what gets sent over the wire, I'd have to modify the DSL's sort of code. Is that going to be a lot more? Is that harder to do?
Conceptually, it's once again, it's still just code, right? So you're thinking about this as a library that you install, but instead of it being a library of utility functions that you then have to import and call and whatever, it's a library that gets applied, essentially extending the language at compile time. So it comes back to, in some ways, how are you managing that code, right? If it's a third-party library, it's going to be something where you're either going to submit pull requests to change it or fork it. If you control it, like this could actually live in your code base. Your Babel config can reference local packages and things like that to compile. So it could just be a different way of organizing your own code base. Like when I've used DSLs, coming back once again, I've done this much more in Ruby land. There it's essentially, you usually use it for a library of some sort. So you're using this library and it has a particular way of interacting with it. And because Ruby, the language itself is able to do the same sort of, like you can change fundamental pieces of the language in a way that you can't just raw do in JavaScript. It can expose an interaction form or a language that reads like English or reads like whatever the DSL is that you're trying to, or whatever the domain language is that you're trying to model there. So this would kind of be like that. Like there it's just another library you import. Here it's a library, but it goes into your build step rather than into your, like it's extending that view of your stack, right? It's saying, okay, my stack now goes down to the level of I can plug additional things into Babel.
I just had another thought. Like, could it be used for like games? Like I know in a lot of games you specify the layout of the level, usually like in some weird kind of 2D array structure or some like long multi-line string where like, you put like a 1 or a 0. 1 is like there's a wall there, or 0 if like you're making a grid game or something. Like there's all these weird things you do. Could you just make something that's like part of the language where you just more naturally specify that structure?
That's the cool thing about DSLs. Once you realize, like once you have the tools for creating the DSLs, which I think is what Kevin's saying about now with Babel, you can basically create a DSL for anything. Heck, even a fictional snake language. And so it's really, I mean, if you can think up the actual language, you have the tools to build it.
I'm trying to think of if the creator of Splunky did that or not. I might actually be remembering that wrong from the book that he published about how he was generating those maps, but that's a really compelling idea.
I didn't write a DSL, but I did write a little bit of a rap for this show, and I thought I would do it as an outro. So what do you guys think? Will you humor me and listen to this rap I wrote? You're all mentioned by name.
Oh, wow.
I don't think anybody's ever written a rap for me before.
Well, then this is your day, my friend. There ain't no party like a JS party, because a JS party don't stop. Unless we on hiatus because the schedule ate us, but now we gonna finish on top. Suz is here. She's a no-op cat. She live codes on Twitch. I'm down with that. Kevin Ball helped lay the foundation. Now he's here to party with the JS Nation. My man Feross, the mad scientist. No one knows what his last name is. See you next week, same time, same place. If you can't make it, punch yourself in the face.
Yeah, I'm more impressed than I thought I was going to be.
Well, I don't want you to think that I took a long time to write that, but I've been crafting it all week long. No, just kidding.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast and fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week.